So let's get started with what was my goal? How did I actually get into machine learning? I had a very simple goal. I have on one side bank transactions, and I want to get categories out of it. I wanted to save money. I wanted to figure out where money goes, and I wanted to figure out how to save money based on that. Now, when I tried to figure out how to do this, I was just like, okay, I have this text and I just need to get into that text. So first, of course, in high school, I was like, okay, I can just write everything manually in Excel. That worked for about 6 months until I gave up. It was accurate, but a lot of manual work. But then I gone into uni, and then I was like, oh, wait, I can use C# for this. And I tried to do rule engines. I tried to do like 3 different versions. They all end up with one very significant problem. You have to maintain a database over and over. It's almost like you need to make it learn on its own. And that's where a few years later, I was like, that sounds like a machine learning problem, doesn't it? And I was like, machine learning has to be the answer. And I quickly realized that one does not simply learn machine learning. At least that's what used to be true. Now it's a little bit different. And the reason why that was the case is because machine learning, and when you learned about something, then you realize, okay, to better understand that thing, you need to learn other things. And then you realize that the other things as another rabbit hole. In order to understand those things, it's another rabbit hole. And then you spend a couple of weekends and you ask yourself, what did I learn? I know how machine learning works in theory, but I don't actually know how to use it. And, like all very ambitious projects, time is infinite, but I never seem to get enough of it. And it ended up in the Field Dreams drawer.
Muchos memes el día de hoy. ¿Qué onda? ¿Qué onda?
And that was true until ML.NET came out. If I remember, it was 2018. And what they said is very, very interesting thing that really hooked me back to the machine learning. It's not just for .NET developers. We also did need to have machine learning experience. And I was like, yes, I want this. I don't want to learn everything about machine learning, not at the beginning. Later, when I have something.
Es cierto eso. Prometen como que les dicen que no necesitas tener experiencia con machine learning. Pero es bastante, no sé, extraño decir eso.
It's simple yet powerful, like all .NET libraries should be. It's already been powered by a lot of Microsoft products already when it was launched. Now it's being powered by a lot of different various scenarios, which I'm sure we're going to hear a lot today. If you already have a data scientist and they're already doing machine learning, it already supports some of the machine learning models like TensorFlow and Onyx. So you don't actually need to use ML.NET to train your own model. And in the end, what hooked me the most at that time was it has one of the most powerful samples in GitHub that I managed to find at that time. There was the GitHub issue classifier. I literally just swapped their Excel with my Excel, removed a couple of columns, and I was just like, wait, did I just done what I was trying to do for so many years? And it's done in less than an hour.
Sorry to interrupt you there, JK. Would you be able to hide?
Para los que están viendo ahí, es una retransmisión de un evento que está en vivo. Ustedes pueden ir a verlo directamente. Aquí voy a estar tratando de dar mis comentarios. Pero el evento está siendo retransmitido en otro canal. Está siendo transmitido, ya no lo estoy retransmitiendo.
Place in Excel and bang, done. And this is why I'm so really hyped up about ML.NET, because it managed to get me into machine learning really, really quickly. And that's also what I'm seeing with a lot of people that I show ML.NET, that they actually are able to get into machine learning and start learning the more difficult things about machine learning after they start to understand, oh, okay, that's how it works. That's all of the caveats I need to understand, and understand how now things can go wrong because I have an actual thing that works for my scenario. All right, now hopefully I got you hooked so that I can take a step back and show you what machine learning is. So, because at the end, I'm going to show you that ML.NET Model Builder can do everything I'm going to show you right now, just in a couple of clicks. But if I show you this now, you won't appreciate or understand what's happening. But if I show you this now, you'll be like, oh, all of this stuff is happening in a couple of few clicks.
Y bueno, ya saben, cualquier duda, si quieren que les traduzca algo, me dicen. Feliz de hacerlo. Les voy a hablar de qué es Machine Learning.
The best explanation I managed to find is to compare it with classical programming. So first, if you look at the classical programming, we have rules and we have data. If you're a developer, you might get rules as specifications for a specific feature and data like inputs in your form. And then you write rules, and when you process all of them, you get an answer to the user. Now with the machine learning, it's a little bit different because you need to have all of the data as well as answers ready ahead of time. And then you put that into machine learning, and then as a result, you get rules, which you can then use in classical programming, for instance, to get the right answer. So you wouldn't need to write the rules in the classical programming. So it's kind of like a reversed from the classical programming. And to give you an example, I think rock, paper, scissors is something that a lot of people understand. So if you have rock, then paper will win. If you have paper, scissors will win. And if you have scissors, rock will win. And here we have the logic written in a classical programming.
Acabo de poner el link a la transmisión original en el chat por si quieren ir a verla directamente. Si no, quédense por acá y hagan preguntas para conversemos si quieren.
We'll have on one column, it's going to be opponent and some of the combinations that the opponent can do, and another column that we have the winning combinations. So we're not telling the machine learning the rules, we're just saying that for this value on this column, you should get this value on that column. And this is a very simple example, right? But what if we complicate it a little bit? There's a game called Rock, Paper, Scissors, Lizard, Spock. And now if we add new rules to it, which no longer goes one-to-one, but you have that, say, scissors can not only beat paper, but can also beat lizard. Now, the classical programming would be a little bit more difficult, but for machine learning, everything remains the same. We just have an Excel with, for what opponent gives you, this is the winning combination. And you can add as many different rules as you want, and the machine learning will learn from the Excel.
Humberto. Este ejemplo está medio raro. Buenos días Luis Fernando. Sí, es buenos días.
Tries to learn from the data that it has, rather than you needing to write it manually. All right, and you might heard about machine learning being able to improve over time. So how does machine learning improve over time? So what we do is first we have training data. Imagine that Excel that I showed you for tic-tac-toe, sorry, not tic-tac-toe, rock, paper, scissors. And then we put it into a machine learning training algorithm. And then we get out of that a model. You imagine that model to be like a
Buen día, Manuel.
Of determining that scissor, that for scissor give paper.
Yo, Ricardo.
And this is not where the story ends. we now need to deploy it to different devices, like desktop and mobile. We need to deploy it to web. We need to deploy it on IoT Edge. So we can use that model. And this is where ML.NET is really good, because we can actually deploy on all of those devices. But this is not where the story ends either. Once we use this model in production, we can actually get feedback, whether it's that from the users who uses our application. It might be, for instance, from the IoT devices. Say that our drone has flown in conditions that hasn't flown before. It can give us the feedback how it behaved in those conditions, so the next time it could improve. Then what we do is we collect all of this feedback, we try to improve that data, and we trickle that back to the training data. And this is how machine learning gets continuously better. So if you ever wondered, okay, machine learning does get better, but how? I hope that you now have a better understanding how the whole cycle works. All right.
Algo que me gusta de Machine Learning.net o ML.net es que tienen como que cubierta toda la parte del ciclo de vida de Machine Learning, lo que acabo de describir.
Machine learning. And to better understand what that is, we should look at different categories of machine learning. For instance, the simplest one is supervised learning. What it means is, like we have rock, paper, scissors, we had labeled data. So for specific columns, we have a specific category that we want to target, or a particular value that we want to predict or forecast, and that's labeled data. We want to get from one data to another data. The simplest example of that is classification. Say, for binary classification, we want to determine if a tweet is positive. If it is, it's going to be yes. If it's not, it's going to be no. Multi-class classification would be if you want to determine what apples do we see. That is usually supported by decision trees. Then we have regression, another subcategory where you can use it for house predictions, stock price forecast, and things like that. And then we have unsupervised learning, which is unlabeled data. That means that we don't specifically tell the machine learning what we're looking for. We're trying to determine that indirectly. So let's go to just a moment. And one of those examples is clustering. A most popular example of clustering is product recommendation. So we're trying to find, for instance, buyers that purchase similar things. So we cluster them together, and then we can say, okay, for this purchaser that buy all of this stuff, other people in the similar group bought all of that other stuff. So we can do a recommendation for the things they haven't bought yet. Then we have dimension reduction, for instance, which allows you to reduce the complexity of the data that you have. And that can allow you to auto-generate.
En el curso de fundamentos de datos hablamos de esta parte de reducción de dimensiones, por si quieren saber más.
The last big category is reinforced learning, which I believe we're getting more and more nowadays. It's a machine learning that basically tries, fails, learns, and then repeats until it masters specific tasks. And that would be, for instance, self-driving cars. That would be in robotics, for instance, if you have looked at the robotics, dynamics robotics, I think it's Boston Dynamics. They have to use reinforced learning a lot. And in games, we're getting more and more reinforced learning. And it's really cool because you can actually make the AI learn on the fly, which is great for gaming. And this is just a oversimplification, just a couple of things that I cherry-picked from the machine learning. There's a lot more to it. And before I move away, I just want to give you a little bit of glimpse of what it means. For instance, if you want to do multi-class classification in this machine learning path.
No. De hecho, esta conferencia es de Machine Learning con C#, bueno, con .NET. Les recomiendo Python. Y es que van comenzando, pero si tienen experiencia con C#, les recomiendo ML.NET definitivamente.
But basically, each trainer is specialized for different kind of data. Some is great for big data, some is for small, some for repeatable data, some for unique. And you can read about the trainers if you're interested. There's cheat sheets for that to figure out which trainer you might want to pick based on the data you have.
Curioso
But
que
we
está
don't
utilizando
actually need to
recursos
know.
de scikit-learn.
There's a lot more about machine learning than just this.
Sí, el curso es con Python.
.NET allows us to access most of what we see here very simply. Right now, unfortunately, reinforced learning is not available, but there's a couple of .NET libraries available that allows you to do reinforced learning if anyone is interested in that. All right, so if I want to get started with machine learning, now let's put aside frameworks and stuff like that. If I just want to learn what type of machine learning I need to look at, how do I start?
No es scikit-learn. Tienen su propio framework.
Out what is the scenario you want to achieve. So what would be a scenario? Well, is a tweet positive? Well, that would be binary classification. How much or how many of something you want to figure out. Then categorizing bank transactions. That would be multi-class classification. What category you want to choose. House price prediction. That would be regression. Again, very similar to a tweet, how much or how many, but just getting a bit differently. And product recommendation. That would be clustering, which group the specific data belongs to. And there's few caveats when you start with machine learning. Machine learning won't magically solve all of your problems. You kind of have to understand your data because you have to guide machine learning toward the right solution. I'm going to show you in the real demo roughly what that means. And you should start with something simple like classification. In our case, we're going to start.
Es bien raro porque muchas veces algo que he visto es que cuando la gente llega con problemas que supuestamente ellos quieren utilizar Machine Learning, a veces la solución más simple y con lo que les recomiendo comenzar es con simples reglas. Digo, dependiendo del problema, pero a veces ni siquiera se necesita Machine Learning. Es simplemente automatizar el proceso de algún otro modo sin utilizar necesariamente Machine Learning.
And when you go to ml.net, you used to have this page where it just show you all of the possible scenario that you should start. That's the first thing you should do is like, what thing I want to build first. And when you go to ml.net model builder, that's also roughly the thing that you get. And when we look back into the original flow, we had training data, ML training algorithms, and then model. ML.net replaces this middle part. We still need to have training data, and at the end, we'll get a model, which we then consume in the application with help of ML.net. We have a bit of a problem if we just start directly with ML.net SDK, because it kind of wants us to select what kind of trainer we want. So how do we solve that? Well, ML.net Model Builder comes to the rescue, which essentially is just a wizard for ML.net SDK. So it uses ML.net SDK and it will generate the code for you. And what it does, it will pick up the best trainer for the scenario you want to pick. And it will also...
Tengo 3 videos. Ahorita les voy a pasar uno que me gustó bastante. Que hice sobre email.net.
What I'm going to also show you, it allows you to do really quick prototyping. You can quickly change the shape of your data, what do you want to ignore, what do you want to change to something else, and I'll show you that as well. To get started with ML.NET Model Builder, I'm going to show you the Visual Studio variant of the ML.NET Model Builder, but you also have VS Code version, which is supported on Mac, Linux, and Windows, as well as a CLI version of that, which is also supported on all of the platforms. And to get started, I believe you still need to search for preview features in Visual Studio and just make sure that you have enabled ML.NET Model Builder. And if you don't have that, you can just go to the .NET, Microsoft.com, apps, machine learning, AI, ML.NET. But the easiest way is just to type ML.NET, and it's usually the first.
Me sorprende cómo está utilizando Bing. De verdad le gusta Microsoft.
And get started in case the instructions are a bit out of date. All right, now let's get started with the demo. And what I'm going to do is I'm going to have a pre-existing data set, which is going to be from a bank that I use, then migrate it to a financial app that I used for years, where I manually classified all of the data and then export it to CSV so I can import it into the ML.NET Model Builder. And this is what the table looks like for the ML.NET that we're going to use. We can see here we have dates, we have account, that is credit card or debit card, the category, the one that we're most interested in. Tax, this is a little bit tricky one because it's a column that I manually edited in the application. So this one can cause a little bit of problem if we want to do automated machine learning. Then we have expense, we have income, in this case it's all zero, the currency and all of the other details. And at the end, this is the main thing that I want to use to for classification is the description of the transaction. So this is going to be our main focus. All right, finally, demo. So let's go to Visual Studio. I already have prepared here a project. And just to verify that you have the extension installed, just go to the here, ML.NET. Actually, just type ML. Just make sure that you have ML.NET Model Builder installed. And if you don't have it, you can just search for preview. Builder. Now to get started, we right-click on a project. We do add, we go machine learning. And what we'll get is picking up a scenario. What do we want to actually build? Now, over here, we start with text classification, which is the multi-class classification, value prediction, which is regression, image classification that uses TensorFlow, another machine learning library. Then we have recommendation that is clustering and object detection, which is done on Azure. If I, for instance, go to image classification, you can see that I can actually select multiple environments, but most of them right now only supports CPU. And if I scroll down, you can actually see some limited scenarios. So for instance, if you're interested in forecasting, which is predicting a
Siento que
value
el
that
código
will
se va
be,
a ver muy borroso. Pero bueno, vamos a ver.
which tries to predict what price would be based on parameters. You can click on this and it will redirect you to a URL to a GitHub sample that you can then clone and then retrofit for your own scenario. As far as I know, I believe Bree will confirm that all of these scenarios are later going to be supported as full-fledged scenarios in ML.NET Model Builder, so you can use it without, you can do these samples without writing any code. All right, let's go to text classification. We select the CPU, and now we start here by adding data. We're going to start by adding unfiltered bank transactions. You can also select SQL. Let's just go there. You can connect to a SQL database. I got a CSV, so I'm going to stick with CSV. I think I'll need to just quickly do that. And what I want to do next is predict, select what columns I want to predict. In this case, it will be categories. And over here, we can see a couple of lines of code, a couple of lines of data, 10 of them, what we're actually importing.
Esto que les está mostrando es una gran tendencia que viene en la ciencia de datos, que es literalmente utilizar un modelo que les va a decir cuál es el mejor modelo que ustedes van a conseguir, que ustedes pueden entrenar.
How long to process. It does suggest 10 seconds for under 10 megabytes. I would say for this particular machine, I'll just put 30 seconds. And now we can see down below, over here, that I started training. You can see the trainer. So this is the missing piece with the ML.NET that you need to know which one to use before you can start using, say, multi-class classification. ML.NET Model Builder does that guesswork for us. It actually takes the data, tries to figure out, okay, which trainer would be the best, and then tries to run machine learning algorithms on it. We got a result. It believes that average perceptron over is the best. Now I can put a little bit more time. I think I would need to put 2 minutes because I'm streaming and all of that stuff to get more machine learning algorithms, but generally the first one is the best one. And I'm going to go next. I'm going to hide here. And we are now at the evaluate part. Now we actually have the model. Now we could just go next, 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 and we will get to the code. But we can actually try out how our machine learning model actually works. So for instance, I can do predict, and we get the right prediction. Now, the interesting thing about this model is if I write some gibberish here and I do predict, we have the same accuracy, 98%. And let's write some gibberish here as well. Same value. Here we can write the same same value. Almost looks like it doesn't matter what we write over here. Okay, it seems to matter 1% for
Lo que sucedió es que aprendió de las etiquetas.
if date. Okay, dates seem to
Aprendió de las tags.
something, but I don't really. Okay, if I put it in a lower, in a date that was roughly at the time that the transaction happened, there's no difference. So what that actually tells us that most of these columns actually not required. So what I can do is I can go here to advanced data options, going back to data, and I can look at the date and I can say, okay, not only the ML.NET Model Builder for multi-class classification does not have a specific date type, we actually don't need date types, specific dates and times in combination of those two for...
Es creo que muy peligroso. Puede resultar hasta cierto punto engañoso introducir machine learning de este tipo, porque lo hacen ver como una caja oscura, y mientras que para los usuarios finales la pueden tratar así, los desarrolladores o los científicos de datos o la gente que está viendo esto, creo que a veces se pueden llevar una mala impresión de lo que es machine learning. Lo que está haciendo ahorita es simplemente utilizar una cosa que hace machine learning por él.
Income, it's constantly zero, so it doesn't matter. Now, in this case, expense amount in currency at the same. So I can safely ignore one of them. So I'm going to ignore the currency. In main currency, we don't need it. It's constantly Australian. Yeah, this one as well. And now when I save, we have nice smaller model. Now I can go back, I can train again. Now I'm going to train for 15 seconds. Hopefully the machine is not going to get too busy with streaming and get us the model within 15 seconds. Also, if you have any questions, you can write on the YouTube comment and I'll have a look. All right. Actually, we can see that the training speed has increased significantly. We went from 13 seconds to 10 seconds. So that's because the complexity of training has reduced significantly. Now, if you try to predict, we have still a very high accuracy. Now, somebody who have remembered that I mentioned something about tags, you might have remembered this particular column has been entered manually. And this is something that will likely be empty when I actually get this transaction. And that means that this tag actually is not reliable. In fact, most of the time we'll end up with wrong results because it will expect those tags to have a certain value. So for instance, if I put...
Básicamente lo que sucede es que el modelo se volvió dependiente de la columna de etiquetas y la etiqueta en sí misma, las tags, podrían traducirse directamente en las categorías. Entonces, eso podría considerarse como una cosa que se llama data leakage.
We need to go ignore, save, and now finally.
Es como si uno podría decir que hasta cierto punto el algoritmo está haciendo trampa, porque está viendo una especie de proxy para la columna de categoría. Y ese proxy es la columna de etiquetas. Entonces, ahorita su modelo va a sufrir bastante porque, pues bueno, ya tiene que definir solamente basándose en el precio y en la descripción.
This has a little bit less accuracy, but 80% is still pretty good accuracy. And now if I put something else, it will now treat the .NET Foundation organization as investment, or you could say, yeah, investment. But there's still a little problem with this model, and this is where a little bit of data science and playing around comes in handy, is what happens when I starting to change the amount. So I add 1 0, nothing significant changes. I add another 0. Actually, it has a better accuracy for some reason. I add another 0. Now it thinks that it's something health related. Okay, that's strange. Now I add another 0. Ah, okay, now it thinks it's a transfer, and it thinks like 18%, there's a couple of other things. Now what's going on here?
Muy confundido el
Why
módulo.
adding zeros all of a sudden the machine learning wouldn't work nicely? Well, that's because we have a lot of transactions that are biased toward its specific categories, like health, or what we had previously, transfers, and yeah, health and transfers. It will gear toward those categories because these ones had high values. So it will make an assumption that if it's high value, it's probably that. And it will ignore the description, which should be the main thing that should look. Now, you can solve these problems with data science, make more balanced models and stuff like that. But you can ask yourself, do I actually need expense amount? And after doing some experimentation and stuff like that.
Ahí es en donde entra muchísimo el esfuerzo de realizar análisis exploratorio de datos para evitar estar haciendo este tipo de cosas. Digo, se entiende porque es el demo sobre ml.net, pero el realizar análisis exploratorio de datos les va a ahorrar muchísimos dolores de cabeza.
Which is really awesome. So over here, we literally have just one string. I can replace this. I can see that it's very certain that is investment. I can say remove a good chunk of this, do predict. It still thinks it's a prediction. I can take this text, I can make some random stuff of it because, you know, in bank transactions, those numbers do change. It still works. It still thinks it's investment. In fact, I can remove most of it and it works. It's like magic. And once we're happy with machine learning, now that we managed to do it like sprinkle of data science, experimented with data, trying out some extremes, and then realizing, hey, we don't need that data, we don't need that data. You could even go to, say, the actual Excel, you could open it up, you could fix some of this data manually. You need to close the Excel before you try to retrain it. Because Excel is keeping the file locked. But you can just do this cycle of quickly retraining, trying out, and then trying again without needing to ever write any code. You don't need to generate a new application. It just works. You just experiment until you're happy with the results. And at the end, what I do is add to solution, and then optionally, if I want to do this as a web API, I can deploy this model to Azure, for instance, or if I want to learn more about data science or how to improve machine learning data or how to improve the data, there's also a link here to documentation for that as well. But for now, let's...
No, me provoca sentimientos encontrados porque siento que la prometen bastante y creo que lo están sobresimplificando demasiado, pero de nuevo creo que la clave está en no quedarse con que la idea de data science es simplemente apretar botones aquí y allá.
Of the transaction.
Sí, un clic y a producción, literalmente eso es lo que... Y bueno, funciona para muchísimos de los casos, particularmente casos muy sencillos, pero obviamente algo ya más complejo creo que sí requiere más trabajo.
We're going to see that for Spotify, it thinks it's leisure. Now, it doesn't quite support emojis. I think it's because of the cons application, not the actual machine learning, sorry, ML.NET. But I can also change this to something else. For instance, I can change it to this. And it will work as investment. Now, what I like to do for this demo is I like to replace this output with this output. So all I did right now is just replaced how we display data, how the replace the response, because now I can show you that those lots of numbers that you've seen previously actually are mapped to specific category, original category that we have previously. So here I can clearly see that for most of the categories, this is a very high probability that it is that category, but for the investment, it is a very high probability. And if I, for instance, change this to this one,
No, algo que les recomendaría es que si llegan a utilizar esta herramienta, después traten de reproducir estos resultados en Python, por ejemplo. Hacerlo un poco ya más a mano.
The 1Z Internet Banking, the BPay vConnect. So yeah, you can see that, I can just change a couple of things. If you want to drill in, you can see that the predict is just a static class in this model that you can share in your Blazor application. You can share it in your web APIs.
Dijo Blazor. O sea, lo podemos poner en la web.
That supports,
vamos a preguntar.
I believe it's .NET Standard 2.0. We can actually verify that. Yeah, .NET Standard 2.0. This should work. And as far as I heard, we also might get some support for more scenarios. I believe we have right now the ability to do multi-class classification on existing trained model, but we might get a little bit more later on. All right.
Los resultados serán similares. Ese es el objetivo, esa es la tarea. Poder obtener los mismos resultados con un modelo entrenado en Python, por ejemplo.
For instance, you would love to run this in GitHub Actions or in Azure DevOps as part of deployment. You want to generate a model. Well, for that, we have a AutoML CLI, which is very similar to ML.NET Model Builder, but in CLI. And it works on Linux, Mac, Windows. And it's literally the same thing that the Model Builder uses behind the scenes. So here down below, I'm showing you just an example how to use the ML.NET CLI to get identical result than what I've shown you in the ML.NET. And lastly, I want to show you is, so over here, I have a live demo on this GitHub where I'm using the ML.NET SDK to run it locally on my browser. I can go offline and this is still going to work, and I can use
Eso es una locura.
I can use the
Ya capturó mi atención aún más.
Inside the browser. So this doesn't have to be locked on your web API. You can actually push this to your browser. For instance, if you go to Network Pane and you refresh, I'm literally downloading the model.
Buen día, Wilbert.
I can use it offline. So if you want to build something like that, you can.
Eso es una locura, para que vean. Directo al navegador.
In summary, what I have shown you is how you can import CSV to the ML.NET model builder, how you can tweak columns and use a little bit of data science to get a lot better results, the ending model. Okay. And how you can then generate the project and then use that machine learning model. Oh, and you can now run this in all of the .NET Core application.
incluyendo
And I can
Blazor.
happily say that I have a solution that in the background gathers all of the data and over time adjusts how it categorizes all of my bank transactions based on the feedback that I give it back. So if it doesn't classify something correctly, I just fix it once, it retrains, and then next time it will get it right.
Y bueno,
All right, so that's everything from me. Do we have any questions?
That was awesome, JK. Thanks.
al parecer, bueno, me comentaron que Blazor no está aún soportado por la mayoría de los casos. Pero vaya.
I know a few people commented on the Blazor stuff. There was just a question. Blazor? Question mark?
Blazor. Okay, so if you're familiar with Angular, React, Vue.js, this is something like that, but in .NET.
I think they knew it was Blazor. I think they were just very excited that you could use it in Blazor.
Okay, yeah. So you can use it in Blazor. This is an actual Blazor application, and I can show you that that's the truth, because we should be seeing DLLs. Where are the DLLs? Interesting.
Pues,
I am showing
Dios mío,
all.
ya volvieron mis ganas de hacer esto en
Well,
.NET.
you can see here blazor.webassembly.js. Usually there's a lot of DLL showing over here.
So beyond maybe for like presentations, what would be some use cases for, you know, using ML.NET with Blazor?
All right, so a use case that I'm currently developing for myself is I'm doing a home automation for my home. And what I want to do is I have smart plugs that can track electricity usage. And I want to do kind of two things. One is to figure out in what power state different devices are. For instance, is my desktop in usage or not? Is it in hibernation? Is it sleeping? Is it being used? Then, for instance, Xbox, is it currently idle? Is it updating? Am I using it and stuff like that? So I want to be able to kind of do clustering of those different states automatically based on the device type. So then I can smartly turn them off when they're not in use. And another thing I want to do as a combination of that is to do like a pattern recognition. For instance, if I turn on Xbox, I play it for a day, and then I don't play it for 3 days, and I do this pattern for a couple of times. I want to be able for the machine learning to figure out, okay, JK is playing console, and then after it turns off, it won't be using the console. So once the console is not in a state that it would be updating, it's in idle state, turn it off after a day of not using it, and then turn it back on a couple of days later. So that's kind of the things that I want to play.
La casa de Tony Stark.
There's one client that wants to use it for forensics, which, you know, if you have a company that does a lot of shady stuff, how you can figure out what's the difference between a company that doesn't do shady stuff and company that does shady stuff, based on this, even like based on the public data of what charities they're putting transactions and what frequencies and which charities and stuff like that. It's really fascinating. There's so many scenarios.
Vamos a tener que revisar Blazor en el canal, ¿eh? Uf.
A couple of things that I'm currently working on.
That's awesome. And this particular demo, is it available to the public? Can people check out this demo?
Yes. So this one actually uses the SDK directly, not the ML.NET model builder. But I do have, not for me, I do have, where is it? I believe it's this one. I do have instructions on how to replicate my demo. And it has quite a few of the same suggestions, although I do need to update it a little bit.
I think, yeah, you'll need to make a few updates, which
Ya
actually
está.
that leads me
Vamos
to
a
this
hacer
question. So
algo de esta onda.
in VS 2019 and the model builder that is available when we fill out the form with the sign up for the preview thing. And I can answer that one. Yeah, so
Yeah.
right now we have a kind of a preview build with a private NuGet feed. Just we're just gathering feedback. Anyone can sign up for it. It's just a little more complicated to set it up. So those changes were not reflected yet in JK's talk. So JK, you'll definitely have to update your talk next time. But we're for build, we plan to release that. So it's just in the public NuGet feed with the new features. So a lot of the stuff that JK showed, I mean, all the stuff JK showed will be there, but then there'll be, yeah, exactly. This is the newer version here.
Yeah, I wasn't quite sure if it's safe to do it yet.
Yeah, exactly. And that's why it's in preview. So totally makes sense. By build, we'll have that out, and JK, you'll have to update everything. Hopefully that's a good thing.
No worries. I prefer for things to update over time and getting better than having been static. Like I've been using this since 2018, and I can say there's been massive updates to ML.NET. It's become a lot better in these 2 years, actually 3 years, and it's incredible journey to see all of the changes. Like there's been a lot of feedback that I gave and been implemented, and I'm super happy now. I've showed this to a lot of people and they are also very happy with it. And I hope that everyone that watched this session and all of the other sessions later, you'll see a lot of cool things.
Vamos a darle follow.
Yeah, definitely. And I mean,
Nice.
you know, all the great changes that we've made has been because of you all, right? Because of the community helping us drive the direction and telling us your feedback and what you want. So continue to do that, and thank you for doing that. And we've got another question here. Where did it go? Oh, so what about Xamarin? Is image classification supported? Do you want me to answer that, or do you want to answer that, Jake?
Yeah, you can answer that.
So I guess it depends so these are kind of two questions. So within Model Builder, you can train image classification models. You can train both locally on your CPU, locally with GPU, or in the cloud with Azure ML. And you can see that actually on JK's screen right now, that image classification is there. We also have an image classification API for training that runs on top of TensorFlow.net. So it uses a process called transfer learning. So you can train custom image classification models. And so for Xamarin, kind of. So there is a big announcement coming up for build, which I will let you all in on since you all are awesome. And maybe, I think I might have announced it before, but for build, we plan to have ARM64 support for training and inference. So that is a big one that people have been asking about for a very long time. So I hope you all are excited about that. And that will be, I think build is May 27th, I want to say 25th through 27th. So that'll be one of the big ML.NET announcements there.
Yeah. And yeah, that's one thing that I really wanted, because I want for people to not only be able to just play around with the model that is in the browser, but being able to upload their own Excels, do the training, and then play around in the browser, allowing people who want to follow the things that I do, just do them live.
Right. Yeah.
For us presenters, that is really awesome for others to get that learn, and for others, for the electricity example that I mentioned, that means that you can take your phone, hook up to a service that takes the electricity usage, and then do the machine learning on your phone, for instance, say machine learning clustering on your phone without needing to connect to Azure services.
Yeah, it's really exciting. We're also working on more Blazor WebAssembly support. That one's a bit trickier, but we are working on that as well. But yeah, the ARM one is pretty exciting. So we have it already working also on the Apple M1 devices. So so yeah, so look forward to that. And actually, it's it's open. ML.NET is open source, so you can take a look at. Michael Sharp is the one working on this. He's been doing awesome work. So you can check out what he's been working on, and yeah, and I think there's a whole like design doc for it on GitHub. So yeah, very exciting. Any last questions for JK? We've got a few minutes before.
Bastante interesante, ¿eh? Digo, al final fue el gancho. El gancho total para convencerme. Actualmente no hay. Digo, no era tan no era tan directo la conversión de un modelo en Python, algo que pudiera correr en el navegador. Pero si lo logran, si se logra hacer con este tipo de iniciativas, es bastante interesante y creo que va a atraer mucha gente que puedas hacer esto.
Unfortunately, I wasn't able to get the JK one.
Awesome. So thanks a ton, JK. This was awesome. Great kickoff for our the rest of our conference. And I'm sure we'll be seeing you soon. And I'll get Louise back on here, and then I'll be taking you off the stream. Bye, JK.
Well, thank you for having me, and have a good night. Well, good morning.
You too. And we've got Louise back. You're on mute, Louise. Come on.
Of course.
Year and a half already.
At least once. Well, that was really okay, as always. Awesome talks here. And we saw that a lot of folks were joining from all sorts of places. I believe I saw Germany somewhere.
Bastante
Sudan,
interesante
so
lo
thank
que
you.
se presenta ahorita. Pero de nuevo, tengo sentimientos encontrados con todo este asunto, porque hacen ver como que la cosa es bastante sencilla y es el gancho perfecto. Lo siguiente es que no se deben quedar con esa idea de que el data science es nada más así apretar botones.
Want to use this sort of new state-of-the-art model and are interested in how you can use it with ML.NET. Priyanka is going to show us how. So with that, let me sort of remove ourselves and
se quitó a sí mismo. ¿Qué demonios está pasando?
And just before we sort of start, if you could click the hide button there, that way it doesn't block your slides. Yep, that would be great. Awesome. All right.
Okay, so I'm starting then. It's visible,
no.
right?
Patrocinadores. Oh no.
Visible, right?
It is, yes.
All right. Okay. So thank you, Luis. Thank you, Bree. And yeah, so great event. I'm also excited to, to hear the other talks as well. And very good evening, good morning to all of you. Okay, so it's night here in Singapore, and yeah, I'm excited to be talking about how we used ML.NET to leverage the state-of-art NLP model, which is making waves right now, which is what we call as BERT. Okay. So this is what the session today will be about. It is about a bot for question and answering using BERT. It is a specialized trained version using Squad dataset for question answer purposes. And also, if time permits, we will also delve into Finbot, which is for exclusively analyzing financial statements. We will sentiment analysis of financial statements. So we will see, why we need a specialized model like Finbot for that purpose. And both of these implementations, we will see how we use ML.NET and how ML.NET facilitates a great way to use a Squad bot and Finbot. So this would be how the presentation will flow today. We will discuss about the real case business scenario which we are facing, and what made us look into using
No era el patrocinador, es la siguiente plática.
Okay, so quickly we'll run through the BERT basics, which will just touch upon that because this is not something, which we are going to learn today. We are not talking about NLP or BERT today, but we are more concentrating on the ML.NET implementation of BERT. So how we use that. So this is how it will go. So the current business problem statement which we are facing is, we are an investment house, all right? So asset management and investment house, and that's why what happens typically is we have research analyst and portfolio managers who will have kind of small documents running maybe a couple of pages or maybe 5 to 10 pages, which they call as call reports, which are like some testament to how the client is performing. So some information about client, like the stock holdings, the current financial condition of the client, the current geographical and political situation in which the client is situated, all those sort of things. Who are the major stakeholders? What is the future? What was the past? Why should we invest in this client, and sort of stuff. So it's like a research document, okay, and that will be uploaded into the system, and that will be reviewed by portfolio managers, directors and all to make suitable investment decisions, stock investing and stuff like that. Okay, so typically the data we have collected is maybe over like 10 years, and we have more than 5 million of these call reports, which we term, and they keep on accumulating like every quarter, right? And portfolio managers, when they are going to look for these particular call reports to make some informed decisions, they will not, I mean, most of the time, because a particular company, the scenario might keep on evolving over the years. So let's say given the pandemic situation, maybe pharma companies and IT companies and e-commerce companies, their share prices surged a lot, or their financial situation, stock situation, share prices situation changed a lot. And so hence these call reports will also keep on evolving, right? So when portfolio managers are wanting to search some stuff, they will ask very specific pointed questions like, what was the market share of TSMC in the last quarter? Or what is the shareholding structure for Tencent Music? Or, what is the current initiative for Tesla and stuff like that. Okay. So the before BERT and stuff, so we have been working on this project for like the past 5 years and approximately. Okay, so we implemented the classical Q&A bot with the Azure bot framework, right? So which means we uploaded all the FAQ documents, so most of the questions which the analysts or the portfolio managers are bound to ask, those sort of things. We also tried to implement LUIS, okay, but given the sheer amount of information which we have, and the amount of and the ad hocness of the questions which the portfolio managers or directors or end users can pose to this particular use case is totally like limitless possibilities, endless possibilities. So you cannot really sit and make rules like, if they ask this, then they should point to this document and stuff like that. So it needs to be more than just a solution with Q&A and LUIS. So we need to understand the context of the question which the portfolio managers are posing, and then accordingly search the answer within all these humongous amount of call report documents or text corpora which we have with us. So the workable solution, the robust solution which we look at, it will need an understanding of the statement, right? So there are other AI-based solutions out there using NLP or using LSTMs, right? So long short-term memory, neural networks, and so LSTMs and all. What happens is LSTMs will suffer from short-term memory. So which means if your text is running into pages and you are asking about something which is connecting your first page to the third page, then that long context cannot be remembered by LSTMs to answer a very coherent to give a very coherent answer to the question. So for example, if you pose very specific questions, like if you have a paragraph describing the shareholder structure of a particular company, and the question is, who is the major stakeholder or who is the major shareholder in this particular ABC company?
Ahorita está hablando de muchos conceptos de deep learning. Y es un buen ejemplo. Quería ver esta conferencia, esta plática es la que más me interesaba.
Stakeholder, but then by the third page the context has changed, and maybe due to some business scenario changes the shareholding structure has been now changed and modified, and then you pose a question. LSTMs will not remember that long a context, right? And then of course, another classic example which we have is confusion between words. Like if we were to classify sentences, so consider the two sentences given here, like her skills with hockey stick made her stand out as a player, and the second sentence is her skills with the jockey stick made her win the competition. So now the first sentence is clearly something related to sports, outdoor activities, whereas the second one is related to technology and gaming. LSTMs won't be able to classify the above sentences differently. They will try to put them in the same, in the same class, right? So these are the few limitations which we suffer with the existing solutions, even word2vec for that matter. So word2vec, when you look for word embedding, sentence embeddings, we came across a lot of shortcomings. So I published a blog on that. I'll share the link at the end of this the session. So all the solutions we implemented and what were the shortcomings and why we went for ML.NET and BERT. Okay, so when we talk of BERT, which is bidirectional encoder representation with transformers, right? So it is nothing but just imagine it as a deep neural network. So within the hidden layers could vary anywhere between 12 to 24. Okay, so it has been trained on a huge text corpora, and for various scenarios, like you have QA BERT, you have clinical BERT, you have distill BERT, you have Roberta, and lot of other variants out there. SciBERT for scientific publications. So a lot of versions out there for different use cases. And they provide you pre-trained versions, pre-trained models, which you can then use transfer learning, fine tune on your own data set, and then customize it to your business case or use case. Or maybe if your the pre-trained model.
Bueno, lo de ML.NET solamente se puede aplicar en Blazor y en algunos escenarios muy limitados. No en alguno de estos otros frameworks, no se puede.
As I was mentioning, these BERT versions. So you have the pre-trained models, which is BERT, Video BERT, Bio BERT, SciBERT, Clinical BERT, TransBERT, GBERT. Okay, and then you have a lot of other sample use cases for that. So Video BERT is used for video captioning, predicting the given a set of videos, analyzing what it is for and stuff like that. And they are used across. So Finbot, as I was saying, is used for financial statement analysis. All right. So these are all the BERT versions out there used for different purposes. Okay. And in BERT basics, just remember that compared to all other models out there, which is LSTMs, or we have GLOVE or ULM Fit and all those existing NLP models, the major difference is BERT will parse the text from both the sides, like left to right and right to left. So you can consider it as bidirectional or even non-directional. Okay. And it uses attention mechanism. So attention mechanism is like it will try to think about the context surrounding the word. So for example, if I'm talking about a green apple, for example, then that apple, so green apple, so it will try to always try to predict, like if given the apple, green apple or green and apple, then it will always try to give more attention to what we are talking of, like she was eating a green apple. So when you look at the word eat, then of course it will try to assume that the next two words or the next couple of words would be talking about that eating stuff. So so this is kind of it makes use of the attention mechanism to learn the contextual relationships. And because when it comes to context, right, you need to know the context, like for given a word you need to predict the next word, or given a question you need to pass the text and give the correct answer to that. So which means you need to understand the contextual relationship between words, for which a very very simplistically put, it will be passing the text from left to right and right to left using the transformer encoder mechanism. Okay. And so this is, sample use. I mean, this is a sample working of how BERT is used to predict the next word or the next sentence and stuff like that. And this is
Sí,
exactly
digo, ustedes
what we
pueden
will
hacer
be using
preguntas de
also.
una vez. Bueno, para responder ahí esa pregunta, digo, entre el acento que tiene y el nombre, creo que es del continente, de India. Ajá.
It will have a kind of a token, so that is to mark the start of the sentence, right? Start of the sentence. Then each sentence is marked by the separator token, which you see as SCP here. So the SCP token which you see here, it is a sentence separator. It will be trying to differentiate between like the first sentence, second sentence, and stuff like that. And then randomly, so it is also using something called as MLM, which is like mask language model. So mask language model, what it does, it randomly within a particular sentence, it masks 15% of the words, okay, 15% of the tokens, and then tries to predict it. Also, it will do a next sentence prediction, which means is, for example, if my if the sentence is like my dog is cute and his color is white, or my dog is cute and he is very fluffy, so it will also try to do this kind of next sentence prediction, true or false, like which is the first sentence and is it a logical continuation to the next sentence or to the previous sentence. So this also it will try to do. So mask language model, this we are also using this in our ML.NET algorithm, which I'll share the source code also, and the next sentence prediction, which is like, is it a next sentence or not? Okay. So now jumping into with BERT Q&A. So let me just make it clear that, this is a very brief overview of how BERT works.
BERT es un monstruo. Es un absoluto monstruo. Y lo que se me hace muy curioso es que cómo es que lo va a utilizar con ML.NET. Creo que es el tema más interesante.
That's why this was essential that I at least show this, that how we are masking the tokens and how sentence separator and CLS tokens and start of the sentence and all is used in BERT. Okay. So now when we are using BERT Q&A, okay, so in Q&A we have the squad data set. So squad data set is pre-trained on a lot of pre-existing question sets out there, okay, and the squad data set is available as a ONNX also. So online neural network exchange is a format where you can consume the model between different platforms. So let's say you have a model which is built using TensorFlow, Keras, PyTorch and all, and that you want to consume it in our ML.NET, so then or Azure machine learning platforms. So you can convert them, so it's interoperability between different platforms. So squad, the squad model is available in the ONNX format, and which directly we are using here in our ML.NET. Okay. And so for the question and answer, right, the question and answer BERT, the basic criteria is that, we have a BERT, and then there is an extra vector that will tell us the beginning and the end of an answer. So what constitutes the question, what constitutes the answer, that sort of thing. Okay. So this is about a brief about the squad data set. So you have about large scale labeled data sets for reading comprehension. Okay. And there are about million answerable, 100,000 answerable questions, 50,000 unanswerable questions from a set of Wikipedia articles, and then it has been adversarially written by the crowd workers. Okay, so that you don't have just like very specific matching answers, right? So there's a lot of effort done for building a robust squad data set. Okay. And so in our use case, normally we are not going to use the fine tuning later on. So normally with all the BERT models out there like Roberta, DistilBERT and Finbot and all, what we typically do is the pre-trained model, we just download them or we just consume them, and then on top of that we fine tune on our own custom data set. But for our purpose, like because our document size was not that huge and it was not very specific also, right? So whatever domain knowledge is out there, we are not doing anything different from that. So we didn't do any fine tuning for our purpose. So we just consumed the squad data set as it is, did not do any sort of fine tuning on our custom data set. We did add some words to our vocabulary. So the existing vocabulary within squad model which you have, we added a couple of.
Bastante interesante. Normalmente uno utiliza estos modelos y los hace este proceso de fine tune, es decir, reentrenarlos un poquito más con la información del problema del dominio. Y es bastante interesante que no lo hayan hecho aquí. Madre mía. Madre mía. Déjenme, les digo si pueden subirle la calidad de ese código.
The answer, okay. But what essentially we are trying to do is, so if you look at that, there are two aspects here. So we have a BERT web API, and then you have the ML.NET model here, okay. So BERT web API is just to consume the model which we have built using BERT here, all right. So you will see that, for the purpose of the demo, I have a web API method here, which is a HTTP get method. So we'll be passing the context.
Aunque bueno, eso nada más es el código sencillo de una web API. No hay ninguna magia ahí.
Response we will get will be a token and with the probability. So token is the answer, we'll get back the answer and with the probability. So possibly, there could be scenarios in which there are multiple possible answers as identified by the BERT bot, okay, and then it will align them, it will give them according to the probability, the highest probability being first. So normally if it is one single token with probability support of like 80%, 85%, and etc. But like if there are multiple tokens, because maybe there are really multiple answers, or maybe it was not clear on the question and on the context and the question, and there could be multiple tokens there, then it will order them by probability. All right. So this is about the controller method. What we actually do is, if you look at so this is, as I was saying, this is the ONNX
Increase the code size
for consuming the model which we have there. All right. So just to explain you a bit about ONNX, I'm very sorry that I forgot to include the slide for ONNX. So ONNX is online neural network exchange, which I mentioned earlier is like interoperability between different platforms. So for example, if you look at this is our C# application. Okay, so ML.NET is there, and then you have your model, which is which is created in using PyTorch or any other framework, and then that could be converted into an ONNX and could be easily integrated into your application. So fortunately, if you look at Squad BERT, there is already a ONNX version available for that, which we are directly consuming. In case of Finbot, for example, there is no ONNX readily available version. So which in case, for which we are trying to convert the PyTorch version into ONNX and then trying to consume it. Okay, so more about Finbot later. But this is what we are essentially doing here. So
hey,
if you
Priyanka, sorry to interrupt you there. Could you make the font a little bit bigger?
Sure. All right. Is this okay?
Maybe just a little bit more. Just a little bit more.
Yeah.
Yeah, that's perfect. That's perfect.
All
Thanks
right.
so much.
Okay, no problem. Okay.
Muchas gracias.
So this is where our we are setting up the ONNX transformations. So these are methods. If you so this is the ML context class, which is our a model context. Okay, so this is the transformer. So these are the standard features which you see with ML.NET. All right, and then you have something like these are the BERT features. Okay, BERT features are nothing but like for example, I was telling you, right? So we have the unique IDs, the segment IDs, the input masks, and the input IDs. Okay, so the model which you're consuming, so these are the sort of what you can say data columns for that, right? So you have segment IDs, you will have an input mask where we are randomly masking the input 15% of the input tokens. You have unique IDs, input IDs. Okay, segment IDs are the segments, the sentence. Okay, so segmented sentences. Okay, then sorry. Yeah, so these are some of the methods in where okay, so let us look at the BERT configuration here. So BERT configuration is you're giving like the max answer length, the max sequence length, vocabulary file. Vocabulary file is where we have this vocabulary file. Let me check. Yeah, here. So vocabulary file is the vocabulary file which you have here, which is this file. Okay, so these are the words which you're which you're feeding. So this is kind of your dictionary, data dictionary. All right, so these are the words which we have which we there were a few which is already available out there, and then we have also annotated using the expertise, in-house expertise from our own data analysts, our own business analysts, fund managers, hedge fund, trading algorithm team, and all those things. So they have also contributed to this vocabulary. Okay, and for example, for some sentences, like for example a playing, okay, so that will be split into play, and so ing, so stemming, lemmatization, tokenization, so all of these things are taken care of. Okay, so that's why when you see this hashing here, so hash xing, so this is nothing but yeah, so this vocabulary is contributed a lot by few of the data scientists, data analysts, and NLP specialists, domain specialists in our team. Okay, so this is the vocabulary file here. Okay, and then you will have, yeah, so there are a few methods here, for example, where you're actually predicting. So in that predicting, what you're going to do is you're getting the sentence which we are giving the context which you're passing here. So if you look from our prediction controller, this is what you're doing, right? You're calling the predict method and you are passing the context and the question. So context is the paragraph and question is the actual question to which you want to get an answer to. All right, so if you look at this, so this is the actual the predict, yeah, this is the actual predict method which you are calling. And what you're doing is, so what happens is when you get the question and the context, first you're tokenizing it. All right, so when you're tokenizing it, then which means you're breaking the sentence. So whatever context you have, you're breaking it, separating out, you're doing the input masking, you're segmenting the sentences into different, assigning them segment IDs, assigning input IDs, and all those things. Okay, and after that, you're calling the predict method here, prediction engine.predict encoded feature. All right, so if, whenever after you get the tokens here, so just to show you the tokenized method, yeah, tokenized method, you're just separating out. Okay, so you're tokenizing the sentence, and then you're also giving the
Hola, Verónica.
token in the file, right? So that each sentence is separated out by separation token. So that is the separation token. Tokenized sentences is here. So when you're doing the tokenized sentences and tokenized subwords, right? So after token,
Vean nada más esa bonita sintaxis de regreso de una tupla.
some of the words which you saw in the vocabulary were like this, right? So for example, when the word is a long word like embedding, so it will be broken up into subwords like M, and then bed, bedding, embeddings, like this. Okay, it will be broken up into subwords. All right, so this is what you are doing. You're tokenizing the sentences, and then if there are other words in the sentence which need to be tokenized into subwords, so that also you're doing, you're tokenizing into subwords. All right, And finally, this is the tokenized sentences, tokenized subwords. And after that, these are the tokens which you have. So CLS token, which is like the start of that sentence, separation token, masking token, where we are randomly masking. So the same slide which we have, CLS, masking, separation token. So all these things are also given here, which are the default tokens. Apart from the default tokens, you are tokenizing the sentences, you are tokenizing the subwords, and finally, you are giving out so when you're calling the predict method, where is it? Sorry. Yeah. So when you're calling the predict method, this is what you're doing. So when you're calling the predict method, you're tokenizing the sentences, subwords, and then you get you're encoding the tokens, right? And once you encode the tokens, then you're calling the predict method of the ML.NET, right? So prediction engine, you have this predict method and you're calling that, right? And when you're getting that, when you're getting the best prediction from the result. So best prediction is if you have multiple tokens, then you order them by probability. And let's say there will be some tokens which will be predicted by more than 70% probability, with more than 80% probability, which is like good enough confidence level for us to treat it as an answer, right? So in that case, we are just generally, if the confidence level is more than 70%, you are just returning the first token which is available to you. Maybe for a question, maybe, because all the probabilities will add up to 1 or 100%. So then it will give you 3, 4 words with varying probabilities. But let's say if the first token which is returned back to you is more than 70% probability, we still treat it as good enough to be an answer, and that will be like the best result given to you. If there are different tokens with very close probability in proximity to each other, so 40%, 30% and stuff like that, then you return multiple tokens. So this is what you're just giving out here. Okay, and so you are giving the predicted tokens, and then you're stitching back the sentence together, right? So maybe if it is like a set of tokens, then you are just stitching it back together to make a coherent answer. All right, and you are returning that with the tokens and probability. Most of the time you will be seeing like a single sentence returned to you. Very rarely we have seen like this is we have already implemented it and it is in production stages. So very rarely we see that the stitch tokens are probably 2 or 3 sentences and with very close probability to each other. Okay, so this is the high level implementation. Publishing, okay, because the vocab text is something which we can't really release as it is, because we have words which are very specific to our organization, specific to our domain knowledge, and kind of NDA is there in the vocab text, so we need to get permissions. But apart from that, we have also taken inspiration from one of the similar published library for Q&A BERT out there. So we've taken inspiration from that. So we will be making this publishing it on GitHub for everyone to use with some limitations on the.
También quiero hacer algo con esta herramienta, así que ya vendrán algo en el canal.
Okay, now let us look at the sample paragraph which we have here. You can give any paragraph. So the sample paragraph which I'm doing here is so this is again something which happened just recently. So my husband Amok fell down on the tennis court and had an ACL injury. So these are just $20 is the space character. Okay, so I'm just encoding the spaces as percentile 20 and then feeding it to the query string. Okay, so this is the context. Context is Amok fell down on the tennis court and had an ACL injury. Okay, he got operated on 20th of February 2020.
Y bueno, lo que estaba diciendo es que van a liberar el código en GitHub. Es por eso que les digo, quiero ver este código y tratar de hacer este tipo de cosas. No, es que habrá que esperar que lo liberen.
All right, so let us give this entire stuff to our REST API. So this is the predict I'm calling. context is the entire sentence, and the question I have posed is, so if you look at the question here, question token, question query string. So question is, why was Amog operated? All right, and if you just let it run. So as I said, the tokens are returned. So tokens, why was Amog operated? Because he had an ACL injury, right? So tokens and ACL injury, probability it is 86%. So 86%.
La plática va de cómo utilizar un modelo que se llama BERT para realizar un sistema de preguntas y respuestas. Ahorita lo que le está mandando es un párrafo y le manda una pregunta cuya respuesta existe dentro de ese párrafo. Entonces le regresa esa información. Por ejemplo, ahorita a ver si les pone otro ejemplo. A ver, ese es el ejemplo.
For TSMC, and you can try out. So this is the actual, this is, you know, one of the call report statements which we have about TSMC, the company description, the shareholding structures and stuff. And then we are asking it question. So let us do one of those things also, which is talking about TSMC. So established in 1988, TSMC is the largest independent foundry with 20% market share and blah, blah, blah. And our question is, what is the country of TSMC? So we are asking it about country of TSMC. All right. So we will just give the...
Por ejemplo, en esta pregunta, ahí viene un párrafo con información sobre una empresa y le va a mandar el párrafo junto con la pregunta. La pregunta es ¿en qué país está esta empresa? Y en teoría el algoritmo, el modelo de Machine Learning le debería responder.
It gives Taiwan and the probability is like 100% probability.
Y
So
bueno,
you can play around.
Le dice el algoritmo, el modelo, le dice esta empresa está en Taiwán basado en el párrafo que le mandó.
The time, I should say about 70 to 75% of the time, the answers returned to us in our actual business scenario are quite satisfactory. So this is something, you know, which we are quite happy with the way it has shaped out to be. Okay. So yeah, moving on to Finbot now. All right, so moving on to Finbot. So a Q&A bot was like, you know, a scenario where we are using the squad data set, and because as I said, the text corpus which we have, the text, the documents which we have, the text content in the document is not very specific, right? So you're talking about shareholding structure and you're talking of other, you know, routine stuff out there. So not very specialized. So you have vocabulary which is specialized, but apart from that, the text itself, you need not have any sort of specialized training to suit your business needs and stuff like that. So whatever squad data set out there, BERT squad serves our purpose. Now, when it comes to financial sentiment analysis, okay, of annual 10K reports, specifically annual 10K reports. So what is 10K reports? So it is a comprehensive report which is filed annually by public companies about their financial performance. Okay. Now, typically what happens in the 10K reports is you are glossing over the information. So no company will be very willing to publish about its bad performance or the quarters where, you know, they plummeted badly and stuff like that. So they'll be always glossing over, and doing this analysis of 10K reports requires a lot of understanding of the hidden subtext. Okay, so you're trying to present even the most shattering information very euphemistically, very mildly or very positively, trying to be upbeat about it. So when actually, you know, we are doing this analysis of 10K reports, to understand whether the sentiment is neutral or positive or negative is a big challenge. Okay, so why we need to do this analysis is because, of course, it is a useful tool for investors to make important decisions about their investments. So let's say post-pandemic era, what could be you know, the share prices of all the asset management houses or real estate companies or digital companies or fintechs and stuff like that. All right, so this is like about forecasting what could be the next sector which could be booming or which could be performing badly. So it is a challenging task, financial analysis, because the vocabulary, unlike what we see in your BERT Q&A, squad data set and all, it's very highly specialized. and you don't have any label data in that domain. So for squad and all you have, or your video BERT or your image BERT, you have annotated data sets. You have ImageNet is there. You have for squad you have Q&A. I mean for Q&A BERT you have squad data set. So which has like sufficient amount of annotated documents, text, and the training data itself is very huge. Okay, but for financial sentiment analysis, it requires a very specialized knowledge of that.
Me imagino que este modelo no lo van a poner en GitHub. Porque van a entrenarlo con su texto.
Squad BERT or sentence BERT for word embeddings, right? If you try to use them on your financial sentiments, more often than not, you will be failing to gauge the actual sentiment. Okay, so mostly the sentiment will be positive or neutral only because of the way in which your 10K reports are worded. So let's say if you look at this sentence, shares of food delivery companies surged despite the catastrophic impact of coronavirus on global markets. So now if you were to look at this sentence, it has positive words also like surged, but you have negative connotations also which are talking of catastrophic impact of corona, right? COVID. So which means if your normal NLP models out there are supposedly analyzing this, they will be confused about whether it's talking of positive thing or it is talking of something because of the words like catastrophic, which give a very negative connotation. So is it positive, negative, or is it neutral? Okay, and so it is like depends on the context in which you're looking at. So it is a positive message for food delivery companies, but it is a negative connotation for the entire global market scenario. Okay, so now this is where why it is difficult for 10K reports is because without getting confused with the rest of the sentence, we have to understand in what context the message is positive, in what context it is negative. Okay, so that's why
la primera parte era como tal una especie de chatbot, y esto lo que van a hacer, están tratando de hacer es detectar sentimientos en reportes de empresas.
Q&A BERT and other BERT models, you're using the BERT base and then fine tuning it on your specific database, a data set. Okay, so it is fine tuned for financial domain. Okay, and then especially for sentiment classification. So for sentiment analysis, okay, so this is we are using BERT, you're doing transfer learning, and then you are building our Finbot, and then it is fine-tuned for specifically sentiment classification, sentiment analysis. So for data sets for Finbot are the Reuters TRC2, okay, and this data set is public, but then you need to have some sort of licensed access for that. So financial houses, investment houses, asset management firms will be typically requesting for the licensed access. Okay, and for the sentiment analysis, we are using the financial phrase bank, the data set from financial phrase bank. So this is how it goes. So these are the financial news which you have. Okay, so whatever coming from Bloomberg or your earning call transcripts, annual 10K reports. Okay, so here you have these NLP phase where you will have term extractions, key phrase extraction, and those things. You have semantic annotation, which is like your financial ontology. So you have defined your specific financial domain. Okay, then you have your annotated financial news. Okay, and then you're doing this sentiment analysis on that, and then trying to tell whether that particular annotated news is positive, negative, and then you have this search engine on top of that where it will
digo, es recomendable aprender otras tecnologías, pero .NET sigue siendo una apuesta muy sólida. Sin duda, si quieres aprender otras tecnologías, adelante, pero .NET viene bastante fuerte con Maui, Blazor, y bueno, en general Microsoft se está poniendo las pilas con .NET.
For Finbot, as I was saying, we are running short of time here. So for Finbot, we are trying to do the exact same implementation which we did for Q&A BERT. So we will be downloading the BERT. We will be downloading the Reuters data set, and I think for the annual 10K reports, they are generic, right? I mean, they're not specific to our company or not specific to emerging markets or those things. So we can directly download those sentiment analysis with Phrase Bank and Reuters model, Reuters trained fine-tuned Finbot model, and start using it, right? Problem is in NX format right now. So we are trying to still convert it, and also we are trying to see with ML.NET whether we can directly consume the PyTorch version, okay, of Finbot. So still working on that. That's work in progress. So right now we were just trying to see if we need some specialized vocabulary which is very specific to our markets, which are like LATAM markets and which are TML markets, which are emerging markets and those things. So we were checking with our domain specialists and our linguistic specialists whether we need any specialized vocabulary or the general Finbot will work. So they are still in process of analyzing those things. But this is what we want to achieve. So I'll show you the demo for sentiment analysis. So this is, let's say this will be the UI and users will be copy pasting the entire 10K.
Me engañaron. Pensé que iban a hacer clasificación de sentimientos, pero no, creo que nada más es... A ver.
So let us try to do this in the Finbot and let us see what sort of sentiment it is returning to us. All right. And it's a bit slow here, but then we can also add multiple sentences, so multiple, yeah. And then here it is positive, which is correct. So share prices of food delivery companies have surged despite of the global markets plummeting. So the sentiment is positive, and then you can play around this, try give multiple sentences. But this is what we tend to achieve. This is the final goal we want to achieve, where we will be giving a interface and we will be feeding, user will be feeding it either for Q&A bot, will be feeding context. So that same context they can ask for a sentiment analysis also, they can ask for a question answer sort of scenario also. And yeah, so this is what we plan to do. For 10K reports, it is very important for portfolio managers, especially in this pandemic era, to try and predict the future of certain sectors. So we deal with a lot of sectors like health, real estate, utilities, energy, and stuff like that. So in those sectors you have different companies. So you have in energy sector and all, you have companies dealing with semiconductors, ionic batteries and all. So future of those post pandemic, and are there any new clients which you are supposed to consider before before proceeding for the next quarter and stuff like that. So for all these things, sentiment analysis is really an important use case for us, and this is where Finbot comes into picture. So sorry, this Finbot is a work half done. This is what we are trying to achieve, the same way what we did with Q&A bot with ML.NET. But yeah, so that is about it. So that is about how we use ML.NET for performing our Q&A and Finbot. And I'll be happy to take any questions if there are.
Awesome. Thank you, Priyanka. That was great. Let's see here. Switch back here. Yeah, thanks for that really great talk. It really is, it really shows the extensibility of ML.NET and how, even though the model wasn't trained using ML.NET, right, you still were able to take advantage of it inside of your .NET applications, and use it, right? And again, the other benefit to that, right, is this is a sort of a state-of-the-art model, and that's been tried and true across various domains. So it's really nice to see you actually using this in production. Let me switch here and take a look at some of the questions here. Well, first, let's get this one out the way here. From Andre Abrantes, are the code and slides available anywhere, GitHub, or just publicly available?
Yeah, I just told you, right, that we'll be publishing them on GitHub with some modifications to the vocabulary file, because they have some very specific data, vocabulary.
Bueno, ahorita hablamos, si quieren, de los lenguajes. La siguiente plática no la voy a transmitir, obviamente les voy a poner los enlaces por si ustedes quieren seguir viendo la plática, la que sigue. Esta conferencia va a durar hasta las 10 de la noche, creo. Y bueno, ahorita hablamos de los lenguajes, si quieren.
On your talk. I think Anthony has a question. Luis, could you bring that up?
Yeah, absolutely. So, well, he's got several questions. So one of them is, and I think you kind of covered that, but just to make sure that folks are clear on this question here is, what is the purpose of the
Anduve haciendo un chingo de preguntas.
tokens in your domain specific data?
So I mentioned it, right, because there will be words which will be there will be words which will be broken down into subwords. So you have embeddings. So embeddings would be M, and then you're masking the first two words EM. Those are the hash. Then bed. Then again masking the rest of the things and ing. Those sort of. So you just imagine that when you are working in NLP domain with word to vec sort of things, then you have all these words which you break down into their roots. So playing will be broken down into play, for example. So same way when you have big words, so embeddings or let's say something like if I were to talk of financial markets, something like upsurging, all those things. So the hash is where you're breaking down the words, and then the hashes are the what you can say placeholders for the previous words. So embeddings will be EM, hash, then the next word will be BED, those sort of things. That is the purpose of that hashes in the vocabulary.
Great. Yeah,
Yes,
thank you for
así
that.
es.
That was
Pregunta y respuesta al punto.
have another question here from Gregor, who is actually going to be speaking later today, who really liked your talk. But their question is, you said that you were also working on another model which you wanted to get from PyTorch to Onyx. What are your challenges with that process?
Yeah, so the thing is, so Finbot, right? This is the Finbot which we're talking of, which we are trying to get it into ONNX. See, the challenge right now is nothing as such. The only thing is we are just waiting for our domain specialist and our linguistic specialist to give us clearance that you can directly use the phrase bank or the Reuters model directly, download it, and then convert it into ONNX and start using it. So we are just waiting for that clearance, and that's why we have not yet really implemented any POC or any such thing surrounding that. So that's the only thing. Again, I think that I think I read somewhere. Correct me, Luis, if I'm wrong. That ML.NET also you can consume PyTorch model. Is that right? With ML.NET using some library.
Not yet. That's certainly a question Bree could answer, but in short, it's something that the team is exploring. So, but at the moment, you cannot natively do it. You have to go through Onyx, right? PyTorch to Onyx, but it's certainly something that's being looked into.
And we also requested for the Finbot guys itself to publish an ONNX model and give it to us. Because there are some challenges with the PyTorch to ONNX conversion as well. You see, you get a lot of errors if you try to do that. So we requested like how the squad bot is available directly. Can you have also the Finbot for us? Let's see what they reply. So we have this question on the GitHub project for that process AI. Let's see what they say.
Right. Yeah. Thanks for that. Yeah, that's a really great place.
Ojalá hagan mi pregunta otra
Just in
vez.
general, right? GitHub, if there's questions or anything like that, that's one of the best places where you can go because chances are, if you're asking that question or if you're requesting a feature, you may not be the only one who's thought of this or who's having an issue. So the more visibility, the more likely it is that those features or those issues will be resolved. So we have another question here from Antonio, and this is related to the Q&A. So you have two components when you're trying to use BERT. One is the context and the other one is the question. So in relation to the context, how big is the context the users have to provide for the Q&A? And just to kind of maybe a bit of a follow-up there, right, is it paragraphs, is it sentences? How big is it and what is it?
Okay, so if you look at that, right, for the demo purpose, I just use a HTTP REST function, HTTP REST call. So which means you will have a certain sort of limit on the amount of data which you're passing to the query string. But if you look at the actual code which we are using for production, I'm not sure if you are able to see my screen. Yeah. So here you have post wherein you can give the question view model itself. So there's no limitation on, the amount of data you are giving to the view model. Absolutely. So the view model, if you look at the view model itself, it will have, the view model here, it will have this question and context. So yeah, it's okay. Sentences, paragraphs, anything is okay.
Pero, ok, dice que cualquier tipo de tamaño, pero supongo que entre más grande sea el contexto, se va a degradar más el resultado.
One page of 1 or 2 pages of a Word doc. So should I'm not sure if you're running into tens of thousands of pages, or if you're actually feeding the entire 10K reports to the Q&A bot, how crisply it will perform or how accurately it will give you the results. But a couple of pages, 5 pages, up to 5 pages is still okay and still accept.
Yeah, I think of it, I don't know if this may be a good analogy, but it's almost like watching a movie, right? Like you'll watch like a certain portion of a movie, but if somebody asks you a question when either, it hasn't gotten to a specific scene or something like that, like you can't really answer that because you don't know, right? So it's like, it's very, going back to the name itself, that's why it's called context. It's very contextual. It's like, you're asking me questions, but, it's going to be dependent on, the context of what it is, right? So a bit of a follow-up on that. So there's no limitation in terms of, sort of like what you can pass in through your requests to your endpoint, and there's no limitations that you're imposing. But does the model itself impose like a minimum or I guess maximum number of characters or tokens that you can pass into it?
Not sure. I have to check on that. Not sure. I'm not sure of that. So I'll need to, take a look on that and get back to that. So
yeah, for sure. Yeah. So I know that 10Ks. So many moons ago, I was in the financial services industry myself, and I know that the complexity of 10K reports, because 10Ks, 10Ks, it's just like, hey, you have to report something.
El enlace que le estoy poniendo es el de la plática, porque ahorita voy a dejar de transmitirla para responder la pregunta que por ahí que hizo Verónica. No sé si siga por acá, pero bueno. Y bueno, las siguientes pláticas no me llaman tanto la atención. Mañana va a haber una a las 3 de la tarde, tiempo del centro de México, la cual no me voy a perder porque habla precisamente de Machine Learning Operations.
Problem in terms of interpreting text and analyzing text, but how are you getting around the problem of sort of like, well, the reports themselves are not standards. I can't know for sure that every time in page 1, I'm going to find certain, perhaps revenue figures, or in page 2, I'm going to find this. It's really dependent on the company. How are you overcoming that challenge?
Yeah, right. So for 10K, right, the data scientists which are working on 10K reports, they are extracting only maybe the summary part, or maybe they are doing this web scraping and they are extracting only certain amount of text. So which means, for every 10K reports that are published, even that is not standardized. Like, for example, if you do web scraping using your web scraping tools like Octoparser or Selenium or whatever that is, still 10K reports will not have page 1 could be shareholding information, page 3 could be annual performance information and stuff. So what they have done is they have identified the companies which we are dealing in. So in emerging market equities or in developing markets and those companies which we are investing in right now. So they have collected all the 10K reports of those specific companies. They have developed a framework wherein it's very customized. So very customized, they look for the text which we want to extract. So there are about maybe 5,000, 6,000 reports. So they have defined a framework going through segregating companies by sectors, and for those sectors, at least those 10K reports will have some standard information, standard way of presenting information. They will extract the text. There are outliers, of course. So for those outliers where the web parser throws error, then they will have to manually extract the information and feed it to our machine learning pipelines or to our data lake. Okay, but 70% of the times the framework which they have defined for extracting very specific information from those reports works for us. But yeah, there's a lot of pre-processing work involved to define those framework engine rules. So we have written an engine itself where you will have those markers for specific sectors and segregating the reports into those sectors and then scraping them and taking out the information which we need for sentiment analysis.
Great. Yeah, no, that's really good. Thanks for that very detailed explanation there. Let's see here. Let me just check if there's any more questions in the chat.
I think we covered all the questions I see so far. But if anyone has any more, feel free to post them. Otherwise, feel free to post them in the virtual ML.net Slack community as well.
Yeah, absolutely. Yeah, and I'm gonna paste here into the chat. Again, very much like the last talk, we would love to get your feedback. So if you go to that link there, aka.ms/virtualmlfeedback, this
Ahorita
not
vamos
only
al
helps
link.
us, but also
Pero,
helps our speakers get
les
feedback.
digo,
in
voy a
terms of
dejar de
how,
transmitir
what you
esta
would like to
conferencia.
see
Voy a
them
quedarme
cover
por aquí para platicar
within the
de
domain of
manera
their
rápida
talks. So make sure to
sobre
leave some
el
feedback
asunto de
there.
los lenguajes.
All right, so
Ay, güey, estaba hablando sobre la otra persona.
questions, thoughts that you'd like to leave folks with?
No, right. I think, I'm looking forward to a lot of promised enhancements in ML.NET, frankly, because we try to use ML.NET a lot wherever possible. Even for AutoML, we are trying to use ML.NET in a lot of places. So yeah, I would really be interested in seeing the proposed enhancements and upcoming versions for ML.NET, especially PyTorch 2 on NX. Yeah, so yeah, and yeah, I mean, great job, guys. ML.NET, seriously, like if you want to do simple things, regression models and all, end users were really happy with how you can just drag and drop using the model builder, which is in preview right now. So yeah, so it's really awesome. So yeah, I wish you all the best and look forward to more features.
Thanks so much. Really
you, Virutal.
appreciate you. Yeah, we really appreciate you taking the time to join us here. We know is it early or is it late for you?
It's like
Okay.
just about to clock 12.
Okay.
Midnight.
All right. Gotcha. Okay. So you're almost like JK. It's pretty late for you. So we really do appreciate you coming on and spending some time with us and teaching us. Yeah.
Nice. My pleasure. Thank you, guys.
Okay.
Thank you.
Take care. We'll see
Right.
you.
Yeah, take care. Be safe. Bye-bye.
Thanks. You too.
Bye-bye.
Ahora sí, ahí está. Digo, no tengo idea de qué están viendo ahorita. Ahí está. Ya estamos de vuelta. Vamos a hablar de manera rápida sobre Machine Learning, pues sobre .NET y Python y demás. Este es un patrón que creo que, de nuevo, es algo que yo me he dado cuenta mucho. Y es que muchas empresas, digamos, viejas de tecnología, aún siguen tratando de ponerse al día con nuevas tecnologías. Entonces, tratan de ponerse al día, pero utilizando, de nuevo, por ejemplo, lenguajes como .NET, C#, F#. Bueno, en F# no tanto. Pero están tratando de actualizar los productos que ofrecen, pero sin alejarse de ese stack que ya tienen. Entonces, es un poco, digamos, complicado encontrar ofertas de este tipo, pero de nuevo, no es extremadamente complicado. La verdad es que ahorita cosas como Python, JavaScript y eso llaman muchísimo más la atención, porque son, de nuevo, por ahí alguien mencionaba como de moda. Y bueno, son de moda, pero no sin el afán de que tenga de moda, tenga un afán, suene muy peyorativo, no es denigrar esas cosas, es un hecho, son tecnologías que están de moda, son buenas tecnologías y por algo son de moda en este momento, pero igual su ciclo va a decaer en algún momento y se van a convertir en tecnologías ya un poco más estables, tal vez no tan conocidas, cuando la siguiente iteración del nuevo lenguaje salga. Pero aún así, bueno, viste que estaba Priyanka ahorita hablando de lo que están tratando de hacer con .NET. Y es que precisamente estoy seguro que la mayoría del stack de su compañía gira en torno a .NET y entonces tal vez llegó un cliente o tal vez quieren actualizarse y meterle Machine Learning a su producto. Y como tal, se fueron directamente a utilizar ML.NET, más allá de a lo mejor tratar de traer otros ingenieros, tratar de traer científicos de datos que trabajaran con Python. No, directamente fue, vamos a hacerlo con .NET y ahí está. Entonces, es una de las oportunidades laborales. Algo que también me he dado cuenta es que la mayoría de las empresas que contratan programadores y programadoras de .NET son empresas no latinoamericanas. Y de hecho quería mostrarles, por ejemplo, déjenme ver, si no voy a compartir información por ahí medio sensible. Pero les quiero mostrar, y este es mi llamado a invitarlos a que aprendan inglés. Que le aprendan al inglés, a que traten de esforzarse en ese sentido, porque digo, creo que vale muchísimo la pena. Y bueno, les voy a mostrar mi perfil de LinkedIn. Veamos. Y, bueno, hace tiempo en uno de tus envíos mencioné que iba a dar una prueba técnica. Me dijiste que voy a comentarle. Qué bueno que te fue súper bien y qué malo que sucedió lo de que el cliente lo puso en pausa. Es lo malo. Suele pasar. Y en particular cuando no lidias directamente con la empresa. Pero, bueno, por ahí espero por fin poder entrevistar a tu amiga Flowers y le voy a preguntar sobre qué tanto le piden cosas de .NET. Pero a ver, vamos a ver. Ahí está mi cuenta de LinkedIn. Como pueden ver, casi no reviso absolutamente nada. Y vamos aquí a la sección de Jobs. Y bueno, de entrada se ve que había estado buscando trabajos de Data Engineer y demás. Pero también estuve buscando cosas de .NET. Y por ejemplo, vamos a ver. Vamos a buscar como tal C#. Y bueno, aquí no les piden un lenguaje en específico. Bueno, hay muchos trabajos en los cuales les piden experiencia en un programa, en un lenguaje de programación compilado como Java o C#. Entonces, digamos que si ustedes van con conocimiento de C#, ya lo hicieron. Creo que el buscador está medio jodido. Porque bueno, le puse C# y me está dando trabajos de Python. Vamos a ver si Sharp. Data Engineer. La mayoría de los trabajos, bueno, también a veces es muy genérico, ¿no? Que piden experiencia en un lenguaje como compilado o fuertemente tipado. También puede ser que ese sea uno de los requerimientos y como tal C# es uno de ellos. Lo que no entiendo es por qué me está dando resultados tan malos. Vamos a ver .NET Developer. Ay, bueno, es que los estoy buscando solamente en Reino Unido. Pero, o sea, ¿de qué hay trabajos? En GitHub. Ok. Y este es de Software Engineer. Es por eso que les digo que el inglés es como que la parte más importante. Más allá, por ejemplo, si ustedes tienen entre dos opciones en aprender un nuevo lenguaje de programación al 100% o dos lenguajes de programación al 100% y aprender bien inglés, 1000 veces les voy a recomendar que decidan aprender inglés. Porque, bueno, van a desbloquear oportunidades como esta de aquí. Pero bueno, vamos a ver. Es que creo que en México no está tan no utilizan tanto LinkedIn en mi experiencia. Creo que la experiencia lo tomo en mucha consideración, pero yo considero que pese a ser junior, tengo los conocimientos. Sí, me he dado cuenta de que este tipo de distinciones son bastante arbitrarias. Tú podrías ser junior en una compañía, pero llegar a otra y ser no junior. O, por ejemplo, tú podrías ser un desarrollador, digamos, normal o desarrolladora normal, entre comillas, en una compañía. Pero, por ejemplo, no sé, sabes muchísimo en tu caso, a lo mejor sabes mucho de C#, ¿no? Y llegas a una compañía en la cual te consideran como desarrolladora no senior, desarrolladora, digamos, normal, pero la compañía escribe la mayoría de su software en Python, pero quieren trabajar con un proyecto de C#. Entonces, en ese caso, ¿qué demonios pasa? Tú eres la persona que sabe más de C# en la compañía, tú eres la persona que sabe mucho de ese lenguaje, y sabes mucho más del mismo lenguaje, del framework que cualquier otro de sus ingenieros. Sin embargo, no te consideran como senior. Es por eso que creo que es muy subjetivo esta calificación. Y es algo que más o menos siento que, por ejemplo, en mi caso, creo que me está entre sucediendo y no. Porque, bueno, en realidad la empresa en la que estoy, la mayoría de los ingenieros y de las ingenieras son desarrolladores en Ruby, sorprendentemente. Y creo yo, de nuevo, sin echarme muchas flores, creo yo que soy una de las personas que más sabe de Python. O al menos de las personas que sabe de Python. Entonces, ahí de nuevo como que existe de nuevo se pierde la noción, ¿no? De quién sabe, de quién es senior y quién es no. Entonces, de nuevo, y todo va relacionado con la famosa frase que siempre suelo decir. No es que uno sepa más que el otro, sino que simplemente sabemos cosas diferentes. Vamos a ver. Salió algo de .NET Junior Developer. Así es, así es. Digo, no sé si te refieras a este de acá. Pero ve, por ejemplo, se necesita un desarrollador Junior Developer para unirse a una empresa de ingeniería en videojuegos, en juegos. ¿Qué es lo que vas a estar haciendo? Entregar código seguro y mantenible con las mejores prácticas. Vas a trabajar con .NET Core, 3.0, y ahí está, .NET Core, que es relativamente reciente. También hay por ahí un poco de TypeScript. Working on several large-scale, high-volume web products across a variety of devices. Sí. ¿Puedo enviarte conexión a LinkedIn? Sí, no sé si ya te había agregado. Pero si no, mándamela. Estoy como Antonio Feregrino Bolaños en LinkedIn. Y bueno, aquí les da más oportunidad de ver de qué va la empresa. Vamos a ver si les da más información. We get it, we put you first, we're transparent. More. Ok, me voy a mandar a la página de la compañía. Pero de nuevo, mira, aquí hay otro de Junior.NET Developer. Aunque creo que este no es remoto. Tal vez si buscamos aquí remote, por ejemplo. Y de nuevo, este es en Reino Unido. Pero igual, si tú, digo, no sé si, bueno, me vas a mandar conexión en LinkedIn. Te agrego, pero igual puedes buscar trabajos en Estados Unidos. Y es lo que te digo, a lo mejor son empresas no tan conocidas, pero que alguna vez dentro de su vida, dentro de su existencia, utilizaron C# y están tratando de actualizarse, por ejemplo. Y C# está en muchísimos lados. hay desarrollo web, hay desarrollo móvil, hay desarrollo de juegos. También puedes buscar trabajos de Unity si es algo que te llama la atención. Unity y definitivamente Unity es C# como tal. No hay de otra. Unity Programmer, Unity Developer. Y aquí está, Significant Programming Experience with C# and Unity. Digo, obviamente vas a tener que aprender Unity, pero aún así vale la pena. Entonces C# está, les digo, web, móvil, videojuegos con Unity. El único lugar en donde no veo a C# como un lenguaje fuerte es en el procesamiento, en herramientas de Big Data. Ahí es en donde definitivamente lenguajes basados en la Java Virtual Machine como Kotlin, Java, Scala, y por ahí debe haber otro lenguaje, no sé. Esos Java y la JVM en herramientas de Big Data son los que llevan siempre las palmas. Ahí es donde C# me parece que no sé qué habrá pasado. Creo que Microsoft tiene la culpa por la forma tan privatizante con que se presentaba en el mundo anteriormente, y fue ahí donde Java agarró por los cuernos el toro del Big Data. Pero sí, digo, C# ahí está. En muchísimas partes, solamente no tanto en el Big Data. Y sí, bueno, si ustedes andan viendo por ahí, les digo, no suelo utilizar tanto LinkedIn, salvo cuando de repente cuando estaba buscando trabajo. Aquí LinkedIn les hace tan fácil como nada más picarle ahí a Easy Apply y vámonos. Entonces ya saben, busquen trabajos y vamos a ver, no sé, en Estados Unidos, United States, por ejemplo. Y si se pueden poner creativos y vamos a ver. Machine Learning. Y podemos ponerle ahí como .NET. Y vamos a ver si por aquí dice algo de .NET. No, nada de .NET en específico. Machine Learning Engineer. O también pueden buscar cosas de Azure también. Azure. Y de lo que me ando buscando es de Go. Y casualmente sale que necesitan Go y Python. Así que tal vez de un pronto. Giro mi ambiente laboral. Sí. Digo, busquen oportunidades en adelante, ya sea que trabajen remotamente o que busquen alguna empresa que les pueda patrocinar la visa, les pueda patrocinar la reubicación. Adelante. Me parece que actualmente se ha abierto muchísimo el mundo. Pero sí, por favor, por lo que más quieran, aprendan bien el inglés. Créanme que va a valer muchísimo la pena. Y bueno, aunque no lo aprendan bien, con que tengan el nivel de inglés suficiente para agarrarse de confianza y aplicar a las empresas, con eso tienen. Y bueno, si a final de cuentas terminan aplicando para algún trabajo en el Reino Unido, pues me dicen. Y por ahí, no sé, les comento si hay alguna cosa para la visa o alguna otra duda que tengan, con muchísimo gusto. Y aprovechan, ¿no? Que cambien hasta de continente. Digo, si no es que ya están en España, por ejemplo. Senior Data Engineer, vamos a ver. Azure. Y bueno, si ustedes ven los sueldos por acá, también dense cuenta de que a lo mejor no se comparan tanto con los sueldos en Estados Unidos, pero también dense cuenta que los gastos de vivienda también son un poco más relativamente bajos acá. Pero bueno, vamos a ver, por ejemplo, cuando yo me conseguí el trabajo en el que estoy actualmente, lo que tuve que buscar fue, creo que MLOps, porque era algo que yo quería hacer. Y como tal, MLOps en Reino Unido, y así fue como llegué a mi a mi trabajo actual. A decir verdad, no recuerdo si apliqué a través de LinkedIn, pero seguramente vi la posición laboral ahí en LinkedIn. Bueno, eso sí, fíjense que no sean contract, sino que sean full time o fully remote. Pero sí, de eso se trata. No crean que .NET está muerto, nada de eso. Inclusive por ahí hay si conocen algún lenguaje esotérico, también tienen oportunidad de aplicar ese conocimiento de algún lenguaje esotérico. Y también eso importa, ¿no? Porque a lo mejor la demanda la oferta de desarrolladores de Python o desarrolladores de Python es bastante alta. Entonces igual no sé si los salarios se depriman precisamente por eso. Pero, por ejemplo, de C# y ese tipo de posiciones, a veces los salarios tienden a ser un poco más elevados, precisamente porque son lenguajes no tan, de nuevo voy a decir, no tan comunes, a comparación de Python, por ejemplo, o de JavaScript. Entonces, también en ese sentido tienen una ventaja, ¿no? A lo mejor no hay tantas oportunidades, pero las que hay ofrecen un poco mejor, un poco más de dinero, por ejemplo. Pero sí, ¿desde cuándo quiero hacer como que uno de esos jueves casuales para platicar sobre las ofertas laborales que hay acá? Pero aún no me siento como que con confianza de poderles dar información que les vaya a servir. No digas como Freddy PHP está muerto. Sí, en realidad ningún lenguaje está muerto. Por ahí de nuevo esa controversia hace años surgió con buen Freddy. Me alegra que ya hayan cambiado, que cambiaron esa postura. Pero sí, ningún lenguaje está muerto, salvo tal vez el lenguaje A o el lenguaje B también, ese tipo de lenguajes. Sí. Pero ahorita los lenguajes más de los que todavía encuentras información, que ves gente tuiteando, nunca van a dejar de estar vivos. Pero sí, entonces los puntos clave. Inglés y utiliza el LinkedIn, aunque sea solo para encontrar oportunidades laborales. Y pues nada, sin más, yo creo que ahora sí los dejo a menos de que tengan por ahí otra pregunta. Por cierto, estaba utilizando mi día de investigación para ver la conferencia. En donde estoy me dan un día, los viernes son precisamente, le llaman los Research Days. Y son días en los cuales nos tenemos que aprovecharlos para actualizarnos o investigar algún tema que nosotros queramos. Y después el lunes presentamos algo de lo que investigamos. Y si vemos que va a tener aplicación para el equipo, o podemos dedicarle un poco más de tiempo de investigación, o como tal sacamos esa pieza de investigación y le hacemos una promoción, le damos un ascenso a un ticket ya dentro del el tablero del equipo, para considerarlo ya como una prioridad. Entonces me agrada bastante ese modelo. Así que el lunes les voy a llegar a platicar a mis compañeros sobre que me engañaron, que no me enseñaron cómo utilizar Finbot, pero que está ahí la posibilidad de hacerlo cuando la gente publique el Onyx, el modelo Onyx. Aunque no, a decir verdad, como nosotros trabajamos con Python, podemos utilizar Finbot directamente. Entonces es una gran posibilidad, lo voy a mencionar. Y también la idea de Blazor, Machine Learning corriendo directamente en el navegador sin mayor complicación. Y bueno, me dieron algunas ideas para futuro contenido en el canal, definitivamente. Un poco extraño que esté aquí hablando yo sin música. Vamos a ver si podemos poner algo. Que de nuevo ahorita es viernes. Es hora de disfrutar un poco más el viernes. Digo, disfrutar, yo no voy a salir a ningún lado, no voy a hacer nada en especial. Tal vez aproveche para dormirme temprano, para que no vuelva a quedar dormido como hoy. Y nada, bueno, mañana me va a estar acompañando Ari Reinventada. Los invito 10 de la mañana. Recuerden, no hay curso de datos. Me queda hasta la siguiente semana. Y de ahí, pues vemos qué más sigue en el canal. Les cuento nuevamente que estoy trabajando. Bueno, quiero comenzar a hacer un curso en una plataforma de pago. No me voy a alejar de YouTube. Solo quiero probar una teoría con esto. Y también ya les había dicho, ¿no? Que está en mis planes. Ayer les conté que está en mis planes escribir un libro. Y les prometo que si en cuanto lo logre hacer, ya sea este año o el que sigue, a los seguidores que andan por acá les voy a tratar de hacer llegar una copia. Puedo inclusive una copia oficial. Se va a poner interesante. Para llegar tarde mañana. No, mañana no tengo que llegar tarde porque va a estar Ari desde bueno, tarde, porque ella también vive de este lado del charco. Entonces es tarde para los dos. Creo que para ella es una hora más tarde. España está 7 horas después de la Ciudad de México, 1 hora después de Londres. Entonces, recuerden, mañana a las 10 de la mañana, tiempo de la Ciudad de México. Me gustaría poder decirles otros horarios, pero todavía no los ligo en mi mente. Me acabo de dar cuenta que la música está altísima. Errores de principiante. Pero nada, amigos y amigas, muchísimas gracias por acompañarme. Espero que no se considere que me estaba pirateando la conferencia. Yo nada más estaba aquí tratando de comentar un poco. Y pues nada, ya saben, nos vemos mañana. Pásenla bien, cuídense mucho, por favor. Tomen agua, manténganse hidratados. Tal vez pude haber utilizado el LA Times. Sí, sin duda. Pero me falta mejorarla. Y ya nadie me ayudó a hacer pull requests y nada ahí. Tal vez la retome más adelante. ¿Y qué más? Pues nada. Cuídense mucho. Gracias de nuevo por acompañarme el día de hoy. Si quieren, sigan viendo la conferencia. Mañana también. A las 3 de la tarde va a haber una conferencia, la misma, pero va a haber una plática que me interesa muchísimo, así que lo más probable es que esté por acá también. Y pues nada, cuídense mucho, por favor, sigan pasándose, disfruten su viernes, cuídense de nuevo, no salgan tanto a la calle. Parece ser que podríamos pensar que ya casi la libramos, pero si salen, usen cubrebocas. Eso es lo único que les pido. Y no me olvido. De hecho, ahorita ya me llegó aquí la notificación. ahorita te agrego. Nada más que igual no quería abrirlo en la pantalla para que no compartir datos privados ahí demás. Y pues nada, nos vemos. Ahora sí. Gracias por acompañarme. Gracias, Verónica. Gracias, Humberto Alonso. Que anduvo por ahí, Diego. ¿Quién más anduvo por ahí? Maybe Out. Y Jason también por ahí. Muchas gracias. Cuídense.